All right. Well, good afternoon, everyone. I am Alex Suarez with Texas Digital Library. We'll go ahead and get started. So please make sure that those mics and videos are muted. Going to start recording. Well, Leah just did. Thank you so much, Leah. So yes, good afternoon from Austin, Texas. Thank you everyone for joining us today, and welcome to today's webinar, which is Intro to GIS. This is our first webinar in TDL's new GIS webinar series, so I'm really excited, and thank you all for being here. Like I said before, my name is Alex Suarez, and I am the Administrative Associate with Texas Digital Library. So let me go ahead and get onto that next slide. All right, so some Zoom stuff. I'm sure by this point everyone's very familiar with Zoom, but just in case, for those of us who are new, you want to make sure that your microphone and video are muted. Presenters will also keep their mics and video muted until it is their turn to present. If you want to see who's in attendance, click on the participants icon in the bottom center of the screen. And if you have a question or comment, please type it into chat. We have myself, Leah, and Cynthia Henry from Texas Tech kind of running referee for that chat. You can access chat by clicking on the thought bubble at the bottom right of your screen. All right, so some good old Bill and Ted. We at Texas Digital Library are big fans of Bill and Ted because they are most triumphant, and especially because they believe in being excellent to each other. We at TDL ask that you also be excellent to each other. We are dedicated to providing an experience for everyone that is free from all forms of harassment and inclusive of all people. We ask that everyone here today be considerate and respectful in speech and action, attempt collaboration before conflict, refrain from demeaning, discriminatory, or harassing behavior in speech, and be mindful of your environment and of your fellow participants. Please use chat for questions and comments pertaining to the panelists' presentations and topics at hand. We will save all your questions for a Q&A session at the end of the webinar. And finally, this meeting is being recorded. We will publish slides and recordings and share them with you all in attendance today, as well as our members, partners, and colleagues in libraries and archives. So today's presenters, we're really excited to welcome Michael Shensky, the GIS and Geospatial Data Coordinator here at UT Austin, as well as Nathaniel Dede-Bamfo, the GIS Services Specialist at Texas State University. And so with that, I'll go ahead and stop sharing my screen, and I will pass it off to Michael.
Hi, good morning, everyone. Thanks for joining us for our first TDL GIS Interest Group webinar. I'm really excited to be presenting to you this morning. I'm actually going to be handling kind of a later part of our webinar today, and Nathaniel is actually going to be leading us off with kind of an introduction to core GIS concepts that'll be helpful for us to be familiar with before we jump into the demonstration, where I'll be going through some common GIS workflows and processes using QGIS. So without further ado, I'll go ahead and turn it over to Nathaniel.
All righty. Can everyone hear me? Michael, can you hear me?
Yep.
Excellent. All right. Thank you all for joining us this morning. I hope you're enjoying the cold weather already. Had some warm weather, but suddenly we have the cold. So enjoy it while it lasts. So I'm so thankful for this opportunity. It's an honor to be with you all. And the goal for me here is basically to introduce you to some basic concepts of GIS, just to get you into the whole field of GIS. It's a huge one, but we'll try as much as possible to make it easy and as simple as possible. So in case I'm using too many jargons, please chime in, and I'm going to take some time and explain certain things. So with that said, let me share my screen with you all. Okay. Michael, can you see my screen?
Yep, looks good.
Okay. All right. So I'm joining you from Texas State University, home of the Bobcat. And today we're going to talk about introduction to GIS. So for the outline, we'll start with what is GIS. We'll move on to talk about some basic GIS data models, types of GIS data we have, and what are some benefits of GIS. You might be wondering, what am I going to use GIS for? And then we'll talk about some examples of GIS software, introduce you to some basic functions in GIS, and then turn over. Okay, before that, let me put on my closed captions, and I believe it's on now. So that's the goal for today. And then I will turn over to Michael to basically take us through some, GIS functionalities in one of the software. All right, so what is GIS? Anytime I throw this question out there, people are like, well, I don't know, maybe I have heard about it, but I believe a lot of people have done some aspect of GIS without knowing. So examples include using Google Maps, Google Earth, going to the field with a GPS unit in your hand, or just going online, searching for locations, what's the closest coffee shop, or what's the closest mall. So any of these aspects, if you have done any of these things, then you have done some aspect of GIS. So when you are looking for, let's say, the closest restaurant, the closest coffee shop, you are applying something in advanced GIS we call network analysis. So you're trying to find the closest facility. In Google Earth, if you're looking at, okay, where things are located, all these are some basic aspect of GIS. So GIS in general stands for, the letters stand for Geographic Information System. And when we talk about geographic, we are simply referring to things related to our planet Earth. So we tend to use the terms spatial, geographic, geospatial. They are all synonymous, but when we refer to geographic, we are simply talking about things pertaining to our planet Earth. It comes from the Greek word geo, which is earth, and then graphein, which is description of our planet Earth. So geographic pertains to the Earth. When you use the term spatial, it's a more broader term. It refers to any location, be it on Earth or be it on a like extraterrestrial location. So it could be on the moon, it could be on the sun, anywhere. That's what spatial means. So sometimes we use the term interchangeably, geographic, spatial, and then geospatial. Information, we are referring to data and the meanings behind it. And then system, simply a collection of computer software, hardware, the procedures, structures, applications, and all that. So putting all these together, we can define GIS as a computerized system which we use simply to capture, manage, analyze, and then eventually display geographic related data. And what's the goal? The goal is simply to promote understanding and then assist us in making very informed decisions. So let me break it down. So GIS, simply, we are trying to find data from our environment, but the data that we want to capture has to be located. And most of the data that we collect are actually located in space. So let's say I want to find data. Let me use the example of coronavirus. Where are coronavirus most clustered? Is it in the South? Is it in the Midwest? Is it in the Pacific areas? Is it in the Northeast? So once we collect data that we can pinpoint to exact location, we refer that as geographic data. When we collect it, we then ask questions, and that is where the analysis come in. We ask questions like, okay, why do we have more clusters over here as opposed to over there? Or we can ask questions like, okay, what if we don't do anything about this virus? How is it going to spread? Is it going to spread eastward or westward? And then when we answer those questions, we visualize them, basically display them. And I'm going to show you some examples. And the goal finally is to make decisions out of them. Okay, these are the components of GIS. So we have the hardware component comprising of the computers. We have software, which are applications. We collect the data, and then the approaches. So approaches are basically procedures that have been laid down to help us analyze the data. And of course, without you and I, there cannot be any GIS. So people are very important. The organizations behind it, those who design the software, and then those who learn it. In GIS, we have two basic data models. We have what we call vector data and raster data. When we talk about vector data, we are simply referring to data, simply referring to models that are used to capture discrete data in the form of points, lines, and polygons. So another term for polygons is what we call the area. So in vector, we are simply starting from, a basic understanding of X and the Y coordinates. So where the X and the Y coordinate meet, we can capture a point. If the feature is a very simple feature like a fire hydrant, or let's say even schools, we can just capture the center of the school as a point. But if the feature has a linear shape, like a river, roads, or electric lines, then we can collect those features with series of points, and that forms a line. So a series of points connected together with a segment forms a line. In the case of an area, let's say a lake or county boundaries, state boundaries, a country, then we collect the shape of the area using series of points that are closed up. So we collect the edges of the feature, we close it up with line segments, and that forms a polygon. So these are the three main ways of capturing features in our environment using vectors. Rasters, on the other hand, we assume that the earth is covered with gridded cells. So we put sort of like a net on the surface of the earth. If a feature falls within a cell of the net, then we associate that cell with the feature. So rasters represent features using gridded cells, as we have over here. So if, let's say, a fire hydrant falls within a cell, then the entire cell is associated with a fire hydrant. If it's a linear feature, then all the cells that intersect with the feature are considered as part of that linear feature. And the same thing applies to the area. Having captured all this information, we move on to the next stage, which is simply layers. So if we collect several features that share the same geometry or, like location dimensions, then together we call it one layer, a layer. So we can collect layers of like city boundaries or county boundaries, and then we can collect another layer of similar features like streets across Texas, and then the same thing parcels. We can go on and then use raster to capture land usage and then elevation. I want to point out rasters are useful for capturing continuous data sets, whereas vectors are useful for discrete data sets. So in continuous data sets, usually we don't have we cannot determine where the boundaries begin and end. That's the name continuous. So things like elevation, things like our climatic data, rainfall, pressure, and all that are captured using elevation data. So if we capture all these information, then we can ask questions like, how many counties across Texas are intersected or crossed by IH35, Interstate 35. We want to, let's say we are interested in measuring noise pollution, and we know that 35 has a lot of traffic. So we want to find out which counties are intersected by 35. In that case, we have to capture the data, get the layer for the counties, and then the layer for the vectors, for the road vectors. And then we can do a simple geoprocessing to review that. And I believe Michael is going to point out some of these things. So under vectors, we have different GIS data types. Vectors, we can capture vectors as in the format called shapefile, which is very popular, or we can capture them using KML, which is the format usually presented in Google Earth and then Google Maps. And the rasters, we can capture data in the format TIFFs, JPEG, IMG, PNG, and so forth and so on. Then I talk about tables. Any of these data sets come with associated information. So for example, fire hydrant has a location, but it has a name or an ID associated with it. We can also associate other information like, okay, the age of the fire hydrant, what is the current status? Is it working or it's not working? All those associated information are captured in what we call an attribute table. So we can capture attribute tables using CSVs or DBFs. With that said, now let's see some benefits of GIS. Probably you have already recognized some. One of the first things we see, GIS is very helpful with managing our data and integrating data. We can bring in data like the boundaries of cities and counties, and then we can bring in data from the sensors associated with that. So data management and integration is very helpful. Enhanced data visualization. As we know, pictures are worth more than 1,000 words. So in statistics, we have numbers and charts and all that, but GIS will provide you with a visualization of the location. Where are things clustered based on the maps? Better capabilities to answer questions like where are things located? What is there? How many? How much? What has changed since this time? What spatial patterns exist and why? And what if nothing happens? How is it going to transition? So let's see some examples. This is a basic map showing distribution of grad students at Texas State from across the world. Where are they coming from? So in 2014, when the data came in, where are most grad students coming from? Of course, the US, but followed by India, China. So this is where are things? So we can make a simple map like this. We can also make a map like this showing total enrollment, which counties are students coming from. So as you can see, the 3 main metropolitan areas, Dallas, Fort Worth, Austin, San Antonio area, and then the Houston area. And this map is just showing the average age of students, okay? So where are most students, the age of student, most of them, well, all the counties have the younger age, but there are some counties that are sending, students who are quite old, so non-traditional students are coming from certain areas. Another example is simply mapping Twitter, so tweets of people during disaster, where are most tweets coming from? We can just simply map that and then correlate it with places that got flooded and look at certain things. What is the correlation between the amount of tweets and then the impact of the disaster? Regarding GIS software, we have proprietary ones and then open source ones. So under the proprietary ones, the common or the most popular is ArcGIS. So ArcGIS now has 2 versions. We have the old version, which is the ArcMap, or sometimes called ArcGIS Desktop, and then the current version, which is the ArcGIS Pro. So depending on your institution, a lot of institutions have site licenses, but some institutions have limited licenses. So that's one of the most popular software. But if you don't have that, your institutions can still go open. And these are all forms of open source GIS software out there. The most popular amongst them is QGIS, and it's very popular in the Austin, San Antonio corridor. A lot of companies, like startup companies, are using that, but there are a bunch of them. So we can explore as much as possible. And I'm going to wrap up by talking about some basic GIS functions. You can do things like adding data, filtering, and it's not going to be important if I just mention them. These are some of the topics Michael is going to demonstrate. So with that, I'm going to sign off here and turn over to Michael. But before Michael jumps in, I want to ask if anybody has a question. I know it was just a breeze through, so I'm going to pause here and see if anybody has a question about these basic concepts.
We don't have any questions in the chat as of yet, but it was very informative. Oh, here comes them.
All right.
There's just a comment saying, thanks for the overview. It was very clear and helpful for us newbies.
Okay, I appreciate that. Thanks. Any other question?
No, it doesn't look like it.
Okay, all right. I believe more questions will come after Michael does his demonstration. So you can hold on tight and see GIS in action. All right, over to you, Michael.
All right, thank you, Nathaniel, for that excellent introduction. I'm going to go ahead and share my screen, and we can take a look at a demonstration of many of the things that Nathaniel was describing in QGIS software. All right, so I'm going to go ahead and share my screen. Can everybody see? Looks like an application window up here. So
yes.
This is excellent. So this is QGIS. I have it installed on my computer, as Nathaniel mentioned. It is a free and open source application, so anybody could go and download it and install it. It's cross-platform compatible, meaning it will work with Mac OS computers, Windows computers, even Linux computers without any problems, and it's really easy to get set up. Really, it only takes a few minutes usually to get it installed and up and running. So when you open QGIS, you'll be presented with this blank window, and that's an indication that with GIS software, you need to come prepared to supply the data that you want to work with. And so what I'll be showing you today is how to go through some really common workflows, and hopefully that'll help give everyone a better understanding of how GIS software works and what we might be able to use it for. So I've actually downloaded quite a few data sets in advance to prepare for this, but I also, before we even jump into QGIS, I want to show you what that process looks like, because that's really important, right? That's something that everybody is pretty much going to need to go through at some point if they're doing GIS work, is they're going to need to be able to find data online and download it for them to be able to use it in software like QGIS or an alternative like ArcGIS Pro. So what I'll do is really quickly, I'm going to go to a new browser tab, and I'm going to search City of Austin GIS. And you can do this for just about any major city in the United States, and you'll likely find some sort of geospatial data portal. So when I click on that, it takes me to the city's GIS website, and one thing to note is that some cities are going to have multiple pages about GIS. So this is actually not the page I wanted to go to. I want to go to the GIS data page. So keep that in mind. If you're looking for any geospatial data from a major city, it's probably out there. The same thing goes for fairly populous counties and states. Just about every state is going to have a geodata portal you could visit. And all right, so now I have found the City of Austin Geodata portal. And I'll just download a random data set here. So in the City of Austin Geodata portal, there are quite a few data sets that we could potentially draw from here. I'm just going to go ahead and download railroads since that's the first one I happen to stumble upon. So I'm going to click on this. It's going to give me a spatial preview so I can see what that data looks like. And then if that looks like information that I'm interested in working with, I can go ahead and click the export button to download that data. And there we go. Great. So I see some railroads. That's what I expected to see. We can see it's geospatial, right? We see it presented in this map preview. So I'm going to click export. And I'm going to decide to download that as a shapefile, which is one of the file formats that Nathaniel mentioned. So that's downloading. Vector data, like data in the shapefile format, usually is fairly small and manageable, so that's going to download really quickly. I'm going to go ahead and extract it because just about all geospatial data that you download from the internet is going to be compressed, usually into a zip file. And here it is now on my desktop. I'm going to go ahead and copy that to another folder on my computer where I store a lot of my data. And I'm just going to paste that in there. And there we see I have that railroads folder. And if I look in the railroads folder here, we see that shapefile. So this is what it looks like. It's comprised of a few different component files, one of which you'll notice Nathaniel had also mentioned in his portion of our presentation today, the DBF file, which contains the attributes for that vector data set. So I'm going to go ahead and go back to QGIS and let me pull that back up as well. All right, so now back in QGIS, what we're looking at here is our main application window, and there are a few different panels that it's important to take note of. So the first one over here in my top right is my browser panel. And this is where I'm able to navigate to data sets that live on my file system on my computer. And also to even access data that might be available on a server, on the internet, or to access data that might be like on a shared drive. But this is how you navigate to the information you want to load into your document. So I'm going to go ahead and bring in that railroads data that I downloaded from the City of Austin website. And there we go. So it looks pretty similar to what I saw in that spatial preview. You will notice that there is no background information. So I can't really tell that this is, railroads in the City of Austin. So maybe I want to add some additional layers of data. So I'm going to go ahead and do that. And this data set that I'm going to add next is from a shapefile representing the county boundaries for all the counties in the United States. So kind of hard to see with the colors that it's just randomly selected here. So I'm going to go ahead and change the colors of these counties to maybe a light gray. So what I'm doing is changing the symbology here. This is a really common operation in GIS software. So symbology refers to the collection of symbols that we use to represent our data. Now it's light gray. I'm going to make my railroads a little bit thicker, also by adjusting their symbology. And we'll make those maybe like let's do a bright kind of burnt orange color. There we go. All right, so now I can see a clear view of my railroads on top of Travis County, right? So this is Travis County behind me, or behind the railroads, I should say, and I can highlight Travis County and select it using the tools that are available here in my top toolbar. So if I wanted to select Travis County, I would go ahead and click the selection cursor and I could click on it, and there we go. Now I've highlighted it. And so selecting features is really useful for a number of operations, as we'll see here as I go on. So now that I've introduced you to the process of finding data online, there are all kinds of great websites that you can do that from. Many of them are operated by government agencies, could be local government, state government, county government, federal government agencies like the USGS, the United States Geological Survey, NOAA, the National Oceanic and Atmospheric Administration, the U.S. Census Bureau. There's plenty of great websites available online for downloading data. I'm going to go ahead and jump back quickly to Nathaniel's slide so I can kind of go over things in the order that he mentioned them. So first up, I'm going to try filtering data. And so if I zoom out far enough here, you'll notice that I do indeed have data for all of the counties in the United States. But let's say I only want to look at Texas counties. So maybe one of the first things I want to do is filter my data to only show the Texas counties and get rid of, or at least hide, the other counties in the United States. So what I'm going to do is, well, first let me look at my attribute table. So the attribute table is something that Nathaniel had mentioned, where this is where the information about each of the spatial features that we see in our data set, this is where that descriptive information is contained, right? And this looks pretty similar to a spreadsheet, like what we would see in Excel. And this is what we refer to as the attribute table in GIS software. So what I'm looking for here is where the state information is contained. And unfortunately, it looks like in this particular data set that I downloaded from the Census Bureau, the state information is contained in the state FP field or column. And so what I need to do is identify which one of these numbers here, whether it's 47 or 48, represents the state of Texas, right? So we can see that the numbers here range from 1 all the way up to 78. And so each one of these numbers represents a particular state or US territory. So what I want to do is I want to filter out just the Texas counties. And it turns out Texas, the code here for Texas is 48. So that's what I'm going to do. So I'm going to establish a filter on the counties layer. I'm going to right click on it. I'm going to click filter. And I'm going to say that I want the state FP number to equal 48. And then I'm going to click the all button here, and it's going to tell me all possible values that I could use to filter out features. And then I'm going to click OK. And there we go. So now we only see those Texas counties. So that is how we would use GIS software to filter features in a data set. So those features are still part of the data set. They're just being temporarily hidden. If I remove that filter, they'd all pop back up. So it's different than actually deleting data. If I did want to delete data, I could do that too. Just really quickly, I could toggle editing, and I could say I want to delete a particular county here in Texas. So I could select it and hit the delete button on my keyboard. And now we notice that's not there. That's permanently gone if I save my edits. If I toggle editing again, it's going to ask me, do you really want to save that change permanently? If I click save, yes, that data is gone forever. I'm going to actually discard that because I don't want to permanently delete that county. So we can also use GIS software to edit data. All right, so now if I want to sort information, I could do that as well. So if I look at my attribute table again for the US counties, so remember I've already filtered it to only the Texas counties right now. The other counties are hidden, so my attribute table is only going to show me the Texas county information. Maybe I want to figure out which county has the greatest land area. So what I'm going to do is I'm going to double click on that field. So this here, A, land, stands for area of land. And then I'm going to scroll back over here. You can see that Rockwall County is the smallest county in Texas by area. I'm going to double click on this again, and it resorts it. And I see that Brewster County has the largest area of any county in Texas. So there's Brewster County. If I do a reverse sort again, and I click on Rockwall County, that comes up, you can see Rockwall County is really tiny right here, just northeast of Dallas. All right, so now I've covered sorting and filtering. Measuring distances in area. So measuring distances in area can also be really useful. In this case, for our US counties, we happen to already have the area data in the attribute table. So that's something that's already basically pre-calculated for us in this particular data set, but that's not always the case. You might download data for city boundaries or park boundaries, and it might not tell you exactly what the area of those features is. That's something you might need to calculate. So I'm going to bring in a different data set that doesn't have that information so that we can do that analysis. So let's see here if I have a good one. So I'm going to bring in data from a different source. I'm going to bring in data for all of the countries in the world here. And you'll notice as soon as I bring that in, our Texas counties get covered up, and that's because the order of the layers in your layers panel over here on the left, which lists all of the layers in your data set, that's really important. So this controls, the order in which they are drawn. And so if I have the countries on top of the counties get hidden. If I have the counties on top of the countries show up. But if I want to calculate things like distance and area, I need to be really careful about the units of measurements, the units of measurement that my QGIS project is going to be using. And so what I would want to do in advance of doing any of those calculations is make sure to select a projection and coordinate reference system that is going to be using the unit of measurement that I'm interested in seeing my data presented in. So what I'm going to do is I'm going to go to the properties of my QGIS project, and I'm going to look for a specific coordinate reference system. This is called the WGIS84 pseudo Mercator coordinate reference system. It's really common. It's the same one that Google Maps uses, OpenStreetMap uses. And I'm going to click OK. The reason I'm selecting this one is because it uses meters as the unit of measurement. So what this is doing is it's changing a few things. One, it changes the way in which my data is displayed, because it's changing the way our 3D coordinates for the world are being transformed into two-dimensional coordinates in order to display them on my flat computer screen. It's also, like I mentioned, changing the unit of measurement that our project is utilizing. So here, the unit of measurement for this particular coordinate reference system is meters. If I change it back to a different coordinate reference system, like the WGS84 coordinate reference system, we'll notice the world looks very different. Greenland looks much smaller now. And this is using degrees of latitude and longitude as the linear unit of measurement. So it's really easy to change back and forth. So it's not actually changing the underlying data, it's just temporarily changing how that data is displayed in my project. So we see again, Greenland gets much larger in this view. So this controls how our data is being distorted, right? Greenland, it has a fixed size, as do all of our continents and countries, but depending on the projection and coordinate reference system we select, they will look different in our maps. So what I'm going to do here, now that I've selected that, is I'm going to go to vector. So these are tools that I would use to look at vector data and analyze vector data. And we could use the let's see, where is it in here?
Is it the measure tool?
Well, I'm looking for the calculate area tool, which is in one of these basic statistics, geometry tools, add geometry attributes. Okay. So we use this tool to say, I want to calculate the area of all the countries in the world using the project coordinate reference system, which is going to use meters as the unit of measurement. And I'm going to plug in my admin countries layer, and it's going to create a new temporary layer to hold this information. So it doesn't like the geometry here, one of the features. So occasionally you'll run into errors with these things. Let's see if I can just do it for the counties, because it doesn't like that particular data set. So I'm going to go back, try this on the counties. And it runs successfully. So there was some issue with the country data that I was working with. So I'd want to go in and examine which one of those features caused the problem. But now if I open the data set here, we already had that information in there. But you can see it recalculated it for me using meters as the unit of measurement for both area and perimeter. If I want to measure distance, so I'm going to zoom in a little bit tighter here. I'm also going to bring in a different data set. So I'm going to add populated places. All right, so let's say I want to calculate the distance between Austin here in Travis County and San Antonio in Bexar County, and I want to look at the straight line distance between the two. I could use the measuring tool in QGIS, which is inconveniently hidden behind my zoom controls. So I'm going to shift the position of my window a little bit to get around that. I'm going to say I want to make my measurement in miles. So we get to pick our unit of measurement here. And I'm going to select a new measurement, and I'm going to basically connect the dots here from San Antonio to Austin. We'll see it estimates that the straight line distance is about 70 miles, right? And it's about 100 miles or so if we were to drive it. So that seems about right, approximately. And so we can use this to calculate distances. Again, the coordinate reference system here can impact the accuracy of these distances that are being calculated. So you want to make sure that you're using an appropriate coordinate reference system for the data you're working with. All right, I'm going to jump back to the slides again for a quick second and see what else we need to cover. Selecting features and queries. So in order to select features, I mentioned we can use the selection tool right here in the toolbar to click on features here. I can select Travis County. First, you want to highlight the layer that you want to select under your layers panel. So here, now that I've selected that layer, I can click on Travis County or Hayes County or Williamson County, and it selects them. If I want to see particular information about Williamson County, using the selection tool is helpful, because if I open my attribute table, here there's a lot of counties in Texas, right? We have over 250. But where's Williamson County, right? I can find it really easily by clicking this button down here in the bottom left of my attribute table and say, I only want to see the selected features. And there, now only Williamson County shows up in the attribute table. If I want to see all the features again, I would say, show me all the features. And there we go. If we select multiple counties, I could go back here and say, show me only the selected features, and it would show me Travis, Burnett, and Williamson County. So that is one way to select features. I'm going to go ahead and clear my selection. If I wanted to select features by location, so let's say I want to, Nathaniel had a good example in his presentation. He mentioned that we could try and find all of the counties in Texas that I-35 runs through. So I'm going to go ahead and actually run that analysis. So I'm going to bring in the data from the Texas Department of Transportation for our national highway system. Those are really light colors, so I'm going to make those a little bit thicker by editing the symbology. So I'll make those kind of a bright red. All right, there we see our highway network. And what I'm going to do here is try and identify just where I-35 is. So again, I'm going to use a filter. I'm going to say route number equals, and I'm going to find, oops, route number equals, there it is, 35. Okay, great. Now I was able to select just I-35. So I filtered that out, and now I want to figure out which counties it intersects with. So what I'm going to do is go to my vector tools up here in my top toolbar, and I'm going to go to research tools, and I'm going to say I want to select by location. So I want to select all of the counties in Texas that intersect with the features in the national highway system layer, which right now has been filtered down to only I-35. So I'm going to run that. It'll take just a few seconds here to complete. And I'm going to go ahead and close that, and there we go. So interestingly, we see some other counties that are definitely not being intersected by I-35 showing up here. That's due to an issue with our data set, where these are probably state highway 35s or some other, we can actually even take a look at them. So in any situation, when you run an analysis, you always need to think critically about the results you've obtained and think, does this actually make sense? And in this case, what we're looking at is an issue with our data. So we want to go through and actually deselect these because these shouldn't have been highlighted.
You want to check from the attribute table from the highway?
Yeah, actually, let's take a closer look at it. So right now, what we're looking at in the highways table, these are only the filtered segments of highway. And if I sort by route number, we'll see that they all are listed as 35. And some of these attributes are not super detailed. So you can see that IH stands for interstate highway, SH stands for state highway. So let's say I want to identify the state highway 35s. And Yep, so that's the issue. You'll notice those are highlighted in yellow here. The issue is that we have not just an Interstate 35, we also have State Highway 35s that run through some of these other counties closer to the coast. And so what I could do is refine my filter and say I want to only see features where the route number is 35 and the route prefix equals IH for Interstate Highway. Once I do that, those disappear. I'm going to turn my counties back on. I'm going to rerun that vector select by location analysis. So I want to select counties that intersect with the highways. And there we go. So now my analysis is correct. And so that was a spatial query. We could also do attribute queries. So let's say I want to go into, I'm going to remove that selection. And I want to go into counties, and I'm going to open the attribute table here. And let's say I want to find a particular county in Texas, and I don't know, for instance, where it's located. So I'm going to do a attribute query, or select by attribute actually in this location, in this situation. And I want to say, show me all of the fields in this particular data set. I want to find the one where the county name equals, and let's say I want to find Milam County. Maybe I don't know where that is in Texas. So I'm going to type in the name of the county, Milam, and I'm going to click select features. Didn't find it. So that's because the county name, let's see here, if I can find Milam County, might have mistyped it. No, there it is. Let's see. Well, let's say I want to find a different county. I want to find, it's a county I really don't know where it's located. Let's say Briscoe County. No matching features found. Can
you change the case?
Let's try this again. Caldwell County, select features, no matching features found. Interesting. That's probably it. It's the case, I bet. So now if I select features, nope, still not finding it. Let me try a different field. Let's say, let's do the full name. County. Still no matching features found. Interesting. Let me try it on a different data set. All right, let's say I want to find the country of Brazil. Hopefully this works without any issues. So here's the view of the world, right? And we want to find out where Brazil is. Let's assume we don't know that. I'm going to open the attribute table. And I'm going to select by expression. And again, let's try looking at the fields. And I want to find where the admin information equals Brazil. And there's something I'm forgetting here in this particular expression. Oh, that's because it's not in single quotes. There we go. So you do have to be careful with the syntax you're using here in the select by expression. in a live demo, that slipped my mind, and we can see that now that I'm using single quotes instead of double quotes, the issue is resolved. So we can do the same thing with the counties in Texas if we try that example again. Turn that back on, and we'll see that that was in fact the issue, me absentmindedly using the double quotes instead of single quotes. Sorry for any confusion on that. So now if I want to find Milam County, select features, there it is, there's Milam County. Was there anything else we were going to cover? And map projections, which we had already talked about. So one last thing I do want to show, if we wanted to, let's say, make a map of Milam County in relation to I-35, I could quickly do that by creating a new print layout, and I'll call this map 1. And this takes me to the map composition window. I'm going to basically determine where I want the map to be drawn on the page. There's my map, and showing I-35 running through Texas, and I could give it a name or title. So in this case, I want to add a label, and I'll add that up here and call it Texas. And we can include a scale bar down here for reference. And we can include a legend showing all of the different data sets that we have loaded in our document. And we can take these out if we want to. So I could say, I don't want to show the railroads, which I decided not to have in this map view, or the populated places. So we have control over what's in the legend. We can change the units on the scale bar too. If I wanted this to be miles instead of kilometers, we could change the size of the font and the title, so we can make it larger. There we go. And so we could compose a nice looking map. And so then we could export it, let's say, as a PDF. And that's a really common workflow for creating modern digital maps. So sorry, took up a little bit of extra time there, but I do want to stop here so we have time for questions.
Do you want to show the PDF?
Yeah, sure.
And while he's getting that up, there was some talk about if this is going to be recorded. It's going to be recorded, and Alex was kind enough to drop the YouTube channel that it's going to be posted on in the chat. So if you haven't seen that, you might want to do that.
And here is the PDF that was saved. So were there any questions?
At about 5 minutes, if you have any question on the concept or the software demonstration, please.
If nobody else is going to ask a question, this is Cynthia Henry. I was wondering if y'all would talk about the open source platforms. There were so many on your slide, Nathaniel. I wonder if either one of y'all have used, clearly, Michael, you've been in QGIS, but are there other ones that y'all have used from that slide?
Personally, I've used CrimeStat. So QGIS is the main thing I use. I've used CrimeStat, I've used Geoda, I've used SAM, and then MGWR. Pretty much all the ones that I've shown on the screen, due to my job, I had to test them so that whenever somebody shows up, but amongst them all, CrimeStat, Geoda, SAM, and MGWR are very useful when you are doing point pattern analysis, like you want to do spatial statistics, like analyzing clusters, where are things clustering, where are things dispersed, and all kinds of stuff. If you want to run things like spatial regression, yes, those tools are very, very helpful for that. Yeah. Another thing I want to point out, some of the tools don't have the visualization component. They will do the analysis, but they will not visualize for you. So it's always useful, you know, if you have those kind of tools, you get another app that can visualize the data for you. For example, QGIS. So you can combine them.
Yeah, Cynthia, and for my side of it, I on the open source side of things, pretty much exclusively use QGIS because it's so powerful and multifaceted, and there's such great documentation available online, and it integrates really well with the other geospatial workflows that I have set up. But yes, there are definitely some other niche applications out there that are things that are perhaps worth looking into in certain situations.
Very good. I do think we have one question. I don't know if Nathaniel was reading that. So this is from Brian Thomas. In addition to the actual file, is the creating application for a GIS file important enough to try to keep, or could we just use the open software digital preservation question?
That's an excellent question and something I did not mention, so thank you for bringing that up. So this document that we had been working in, this QGIS project, I have not yet saved. And so that is definitely something that could be worth saving. And so what I'll do here to actually save the QGIS file is go to project, and I'll save it, and I'll call it, I'll save it to my desktop, and I'll call it webinar example. All right, and once I've done that, we'll see that this QGIS file now shows up on my desktop. And what is actually being saved here, it's a few things. It's not saving the underlying data. So the data and the map project exist independently. So whenever you're trying to preserve something, you always want to keep that in mind. You can't just save the map by itself and remove it from where the data is stored, because then what we'd end up with is a completely empty map, right? It would look just like this. It wouldn't be able to find the sources of the data. So you need to make sure that you're always packaging and saving the data in the map document together. In the map document, what we're actually saving are things like the symbology, right? So if I were to reopen this later, I would still see that I-35 is red, the background counties are light gray, the countries of the world are light green. Whereas if I were to open up a brand new QGIS document every time and load these same data layers in there, the colors would be randomly selected each time I added the data set, right? I'd have to refilter the National Highway System to only show I-35. That's another, that filter is being saved in the map project. My print composer window and that layout that I set up to create my map example, this is also saved in the map project. So it's definitely worth considering saving your map projects before you close out of the application.
Great, that is so informative, and y'all cannot even imagine how many compliments you got in the chat. Everybody is just very thankful that you gave such a well in-depth overview of GIS. Clearly there's a lot to talk about, so that's exciting.
Yeah, I want to thank both Michael and Nathaniel and Cynthia, everybody that was involved today. It looks like we're right at 12:01, so I'm going to have to put a cap on this very exciting conversation. And there's going to be more webinars coming soon, as well as more activity coming from our GIS Interest Group here at TDL. So if anybody has any questions, don't hesitate to contact me, a.suarez@austin.utexas.edu. Feel free to check us out on tdl.org. And yeah, we look forward to seeing everybody for the next one. Thank everybody so much.
Sure.